let's start talking about this data set. Now, if we're doing this in class, this experiment, what we're going to do, we're going to measure certain things. And then the whole focus of this lab is to understand how the errors play a role if I do an experiment, right? So that's the main focus in this lab. So now the data sets are given here is actually real experimental data which we measured in our lab class. So what we done, we took the meter ruler and then we measure certain things. For example, what we're measuring here, length of the top part of the lab desk and then width of that tabletop and the thickness of the tabletop. Okay. And then you can see by measuring that, I taking that measurement 8 times. So if I measure one time that measurement, I'm using the meter ruler. If I do one measurement, there are certain things important, right? So what are the important things? What's the instrument I'm using? I'm using the instrument here, a meter ruler. So if I'm using the meter ruler, usually meter ruler has the least count. So what's the least count of the meter ruler? What's the meaning of least count? Anybody know what's the meaning of the least count? Least count mean what's the smallest possible measurement you can do by using the instrument, right? For example, if you look at the meter ruler, what are the units you see on the meter ruler? Meter ruler has unit of?
Centimeter, meter.
1 meter, the total length, right? And then it has unit of centimeter and also it has?
Millimeter.
Millimeter, right? So the least count mean what is the smallest possible unit your instrument contains. So now in this case, for the meter ruler, the smallest possible unit is 1 millimeter, right? So that's the least count. Idea of least count is what is the smallest possible unit in that instrument. Now, if you take a measurement by using the meter ruler, every time you take in the measurement, there can be certain error in that measurement, right? That error may be up to 1 millimeter level, or you can still observe 2 millimeter lines very carefully, very clearly in your meter ruler, right? It's visible, it's fairly large. Because of that, usually when you do a measurement, there will be an error associated with every single measurement in that instrument. That's called the uncertainty of that measurement. So which means if you do, for example, let's say I measure length, right? Let's say I measure length in the meter ruler. This is a very large tabletop, right? You know that the lab table, black color tabletop, that's what we measure in here. That's about like 182.5 centimeters. I'm using centimeter units here, which I'm using centimeter units mean least count is 1 millimeters. I can go into first decimal place with every single measurement. And you can see I'm putting the second decimal place too, right? There's a reason for that. Anybody know why I'm adding this 0 purposely?
Shows the significant figures.
No.
It's because it's a measured number.
It is a measured number, but what is the reason why we need that second decimal place?
It's accurate to 100th.
Correct. It's accurate. Very good. It's accurate to the second decimal place in terms of uncertainty, right? Because your uncertainty always half of the least count. Uncertainty is actually least count by 2. By 2, sorry. This one, 2. Least count divided by 2. Technically, if the least count is 1 millimeters, your uncertainty of the measurement is actually 0.05. That's why every time when you do measurement, you may not be able to measure down to that point. That's fine, but you have to represent that decimal place in your measured numbers. If not, your measured accuracy is not properly represented in your data. It's inaccurate. So those are the things which is very different relative to our lecture class, because in our lecture class, we don't really worried about those accuracy or anything. What we basically check in the sig fit, right? If you multiply two numbers, we check the least accurate number and then least significant figure value and then leave it and then so proceed, right? But in the experiment class, we are not really interested those significant figure itself. What we really interested is actually how you reporting your data in terms of accuracy, right significant figures, and then so on. So that's very important, because why this is important now, you have to think about, I talked about report writing earlier, right? Why the report writing is so critically important, because you write something to read by someone else who never done the lab, right? That's the idea. That's what's going to happen when you go into the field, right? You write the report for your boss. He's not going to come into the field. He may have the experience previously, years ago. If he's an old guy, maybe he never been in the field like last 20 years. He never even don't know how the new measurement done. He know basic ideas. He's a smart guy. He know what to look for in the report, but he never been in the field for a while. Maybe in such scenarios, your report is so crucial. If you don't report everything accurately and precisely and correct way, you're reporting something misinformed. Then if that guy is not really familiar or knowledgeable enough to the current world, what he reading, maybe he will take a wrong decision. So that's really bad for the what comes next. So those are the really bad things can happen if your report writing is bad. So that's why I really try to tell this many times, because you guys going to be engineers, okay, not going to be English teachers or psychologists or anybody, okay? So you have to practice what comes next, not what classes you've done last semester or first semester in our Bergen. Okay. So those classes are important, but will not be directly relevant to your engineering career. Okay. Any question? All right, so let's continue. Now, this actually, I say here is standard measurement. The standard measurement, for example, what measurement I am expecting by measuring those, right? You can see I expect about 182.5. But when you go into my data set, on the other hand, you can see each time I measure, you can see I get a different number, right? You can see either it is on last decimal place, that error is changing, or even it's changing a couple of millimeters. Why that happen? Anybody know why there's a error in each measurement? Why the reading is different from each measurement?
Is it human error?
That's a human error actually, yeah, because this is a large table, right? You have to really put very alignedly your meter ruler, and then we using 1 meter to measure about like 1.82 meters. Then you mark that 1 meter location and then take the meter ruler and then align again. Then there's a human error always. So that's why actually you read this different. So which means easily you can see that's the idea of taking more measurement. If you measure once, for example, you measure only, let's take a look at different reading, okay? Let's say you measure once, you read this number. Now you would think that is good, that is accurate. I mean, not bad, right? Standard value are expecting 82.5 and then you got 82.60. I mean, this kind of work, it's nothing much to worry. But if you go into the very high level of engineering production or something like that, let's say you're working on the Boeing, right, in your future, and or let's say you're working for the Intel Corporation for the microcomputers, right? So then that error going to be a disaster. That's a problem. So you can't have that error. Your error going to be, they will give you what the error margin is. Most of the time, either in micrometer level or maybe nanometer level. So you have to reach that level. If your error is more than that, you have to figure out why, and then so on. So that's why the error analysis is so critical. That's why first few lab actually we're gonna give a little bit of focus into that. Okay. And if I see variation, if I measure same measurement many times, then what should I do next? Usually, if you measure more, if you have a data set, what you do generally? You take
The average.
the average, right? That's very simple, right? So I have the length, many data points, and then I have width, 8 data points, and then I have thickness, 8 data points. Let's take the average. Now, when it comes to Excel, now I know some of you might be familiar to do the Excel function, some of you not. Either way, doesn't matter. If you very new for Excel functions, nothing much to worry. You can learn as the class progress. If you know how to do the function, this will be very easy for you, okay? In any case, how we do the function, every function is start with the equal sign, right? Now, let's say this is the average what I want to calculate, right? I don't know the function. Let's say I'm very new to Excel. I don't know what the function is, but I know what I'm calculating, right? I'm calculating average. All you have to do, type the first 2 letters. As soon as you type the first 2 letters after equal sign, you see these terms appear. First term, it say that is a function, you can say fx here. That function is actually returns the average of the absolute deviation. That is not what I need here, right? Let's go to second one. If you go to second one, it says it says the meaning for you, right? You don't need to memorize any of this thing. You can learn yourself. You don't need to take the classes or anything. You can see it's returned the average arithmetic of its argument, which means if you give a data range, it will give you the average. That's what I needed. Double click. Then you see it blinking after the parentheses. Then you go and click on the first cell right here. Then you drag downward direction. Then you can see this whole range of data highlighted. That's what I want to calculate the average, right? Then you close brackets. Then you can see average, parentheses open, B9 to B16. That is my data range. Hit enter button. It will calculate that for you. That's why I mentioned earlier, this is very easy than you are using the calculator, because if you're using the calculator, you have to type each number at a time, and then you have to type all of these 8, divide by 8. So in Excel, it's a one single function, take only like less than maybe 10 seconds to do that. Okay, question. Let's do that calculation for next. Equal sign, AV, average, click and drag, close bracket, hit enter. Equal sign, AV, average, click and drag, close bracket, hit enter. Okay, see now to calculate all these 3 averages, it's going to take like maybe 15 seconds, 5 seconds for each, not even 5 seconds for each. Now, if you do with the calculator, you have to spend like a couple of minutes to do that, maybe 5 minutes altogether. So that's how much time you can save if you do this work right now. These are the places you have to discuss, right? In your discussion section, you have to write a discussion about every table. 1 paragraph for each table, which means for this lab, you have to discuss 1 paragraph for table 1, table 2, table 3, table 4, and then if you get time, then the table 5, which means small, you don't need to write like pages for each paragraph, right? I'm not expecting you to write like half a page paragraph for each table. Just few sentences. How you did the average, what function you use, and then how you did the mean average deviation, what function you use. If you do one sentence for each, you can write easily like 5 sentences per each table. It's not really big deal to do, okay? Very simple. But you have to practice that. Okay, good. Any questions so far? All right, so let's continue then. Now, the next is actually error associated with each measurement, right? Let's go back and take a look. Now, if you have any single measurement, each measurement has an error, right? Each measurement error is actually uncertainty. If you have an analog type instrument, okay, this is important. If you have an analog type instrument, so the uncertainty is the error of that each measurement error of each measurement is actually equal to uncertainty of the instrument. That's important why I call it analog. Analog means like the meter ruler or like anything you physically you do the measurement, right? On the other hand, let's say if you have a digital instrument, like for example, let's say like the stopwatch, right? If you use a stopwatch to measure anything, stopwatch has a scale, right? So the scale has a certain decimal places. Now, what you really do in the stopwatch, you read in the scale. You don't have any freedom to do anything other than reading the numbers given in the scale, right? I can't really do any more reading than what it shows to me. Because of that, if you have a digital instrument, then your error of each measurement gonna be just last decimal place. Follow that question? Everybody get that idea, right? Okay, so seems to be no question. Then let's continue. All right, now which means if I do this measurement, you can see each measurement has this uncertainty, right? Uncertainty of the meter ruler, you know, half the millimeter. And I'm writing here in centimeters, right? That's why it is 0.05 centimeters, right? But if you take more data points, like for example, right here, you can see I have many data points. I did the average, which means my error for this whole measurement now is not 0.05 any longer, because I have many data points. If I do the average, then you have to do what we call average mean deviation. Average mean deviation means you have to take a look how much the error relative to this average value, which means first you have to find, this is L bar, okay, this number is L bar average length, this bar represent the average. So you have to first find what is the L bar minus L for each single measurement. Okay, if you know that for each single measurement, then I can average this whole thing to get the average mean deviation for this measured value average length. That's the idea. However, I will show you in a bit, we can do this long way. That is actually this equation. When you're doing this lab report, this will be useful where these equations are. So this represent the error least count, what we just discussed. I'm going to skip that part. So when you do average deviation, this is the equation for that, okay? And when it go to statistical mechanics, then you will see various different type of average mean deviation they're going to discuss. For example, they would like to mostly talk about standard deviation, okay? But I'm not going to use that during the class. If you take the statistical mechanics later, you will see those things, but this is for only informational purposes, okay? But for this class, we're going to be only working on average mean deviation directly. Question? Okay, let's calculate this one. Now, you know, by looking at this equation, what I have to do, look at this one. Sum of all the di over n. Di is actually, you can see xi minus x bar or x bar minus xi, but is absolute value. Okay, you can see here L bar minus L, absolute value. Let's do that calculation. How you do this calculation in Excel? Check. Due to some reason, my Excel sheet is stop responding. Let me quickly unshare and reshare that again. Okay, sometime it happened. Sometime it happened randomly. Let's see. Should be fine if I reshare that, hopefully. Maybe not. Let me recheck quickly. But I have to do maybe close this file and then reopen, then it should respond properly. Give me a 1 second, okay? Due to some reason, my Excel file is stopped responding. This WebEx, sometime if I share many things that happen, that very normal. Hopefully it's gonna be fine in a bit. Let's see. Okay, now it's good. That's very normal with this WebEx. All right, so let's go back here, and then I want to share that my lab manual too. That will be useful as we progress. Okay, now it should be good, right? You see the lab manual and the Excel file both. All right, now let's calculate this one. Okay, let's delete this. All right, now I'm going to calculate L bar minus L equals sign. If you want to keep any number as constant, you have to type that number. Okay. If you want to get absolute values, type ABS. You can see it returns the absolute values number. So which means ABS parentheses L bar should be fixed, which means 182.61. That the L bar average length minus the L gonna be changing at any given moment, right? At any given data set. Because of that, click that cell, close bracket, enter button. Now this number represent only L bar minus L. Okay. Now you can see in terms of significant figures, that number is not matched. But in terms of decimal places, that number is actually perfect match with this length values, right? Why I keeping only two decimal places visible? We are not interested actually significant figure here. What we interested is the accuracy of this measurement. I can't really do any calculation more than two decimal places accurate. That's the idea there, okay? That's why I keep it to two decimal places. So that's where this significant figure rules, things like that, we're not going to follow as it is with the in the lab setting sometime, because in the lab setting we are more concerned about the accuracy, error, things like that, not the significant figure itself. Okay, significant figure comes the secondary, accuracy and the error comes the primary. Okay, in the lab. Everybody okay with this calculation, this cell? After you do that, if you want to do the same calculation on Excel, you click on that cell. If you look at that, it highlighted in the green color. Right hand side, very bottom, you see the green color dot. You double click on that dot, or you click and drag downward direction. That will do the rest of the calculation automatically for you. Okay. Now that is L bar minus L, that is actually this DI. Now I have to add all the DI divide by N. That is called the mean average deviation. Let's click on this cell, equal sign. You have to take the average of this, right? So which means AV, average, and then highlight this cell, close bracket, hit enter button. So that will do the average mean deviation for you. Now, if you take a look, average mean deviation and the error or the uncertainty for each measurement, now you see why we did that, right? See, this number is 0.12, error for each measurement is 0.05. So those two are not even closer. So that's the idea. So which means if I have more data, I have more error there. So I have to do the data analysis very different way than the data for each single measurement. Okay. Question. Anybody have any question? Okay. So seems to be no problem. So either you're following everything easily, or maybe you're not doing anything. I don't know what's going on. Let me know. Okay. Anybody have any question? All right, seems to be you guys are really good with the Excel. So we don't need to worry about much. That's good. Very good. Then let's continue. Let's do the same thing. W bar minus W equal sign ABS parentheses W bar is 106.5 minus each item number right here. That's the cell value. Close brackets equal enter button. Go back to the same cell. Right hand side very below you will see that green color dot. Click and drag. Then go into average mean deviation cell, equal sign, average, double click and drag, highlight the data set, close brackets, equal sign. Now you can see each time when I do that, that's not going to fit with the uncertainty of the each measurement, right? See that? That's a different number. That's the whole idea of doing this uncertainty analysis, what we call the propagation of error analysis very in detail, okay? Now let's do that for thickness. Equal sign, ABS, open brackets, 2.47 is the average minus each thickness value right here, close bracket, hit enter, and then go back to the same cell, right hand side very bottom, click and drag, go back to the average mean deviation, equal sign, average, and then highlight the data set, close bracket, hit enter. Now when it come to here, you can see there's many decimal places. Now that which I don't need to leave like that. The reason what we're interested here is the accuracy. So how much accuracy my error I can show. In terms of accuracy of the error, I can go into 2 decimal places in unit centimeters. That's the accuracy of the error, right? No meaning showing anything other than the second decimal place because those are not real. Usually when you do the calculation, in this area, when you do the calculation, you can leave it like that. These are not final calculation, but we're aiming, right? So our final calculation is right here. So what we're trying to do, average perimeter, average area, average volume of the object. That's a tabletop, which is a rectangular, 3-dimensional shape object, right? So that's the plan. So after we do that, we're going to report those values right here in terms of scientific notation with the right significant figures and so on. That's the primary goal of this lab. Because of that, at this point, you can leave it if you want couple of decimal place more of every this calculated value, nothing wrong. Okay. But when you come to here, make sure you follow the significant figure and the accuracy rule carefully and then leave the answer correctly. Okay, let's discuss later in a bit. Right here, let's leave a couple of decimal places more. That's nothing wrong. But in terms of final answers, technically, I cannot leave any numbers more than this accuracy of 2, right? You get that idea? Okay, so that's why actually I rounded all of these values into 2. If you want to, for example, now let's say I would like to round this number into exact accuracy in my report. I don't like to leave any extra decimal places, right? So I am more concerned about my accuracy of the measured values, right? So in that case, I want to represent this number only in 2 decimal places. What should I do? You highlight that, click on that cell, right click, format cells, then you see a new window. In that window, you can go into number, first line, and then in the category, select number, and then put the decimal places into 2. Click OK. You can see now you cut down rest of the decimal places. Still, you can see that number is not 0.05 because I got many data points. I'm doing mean average deviation that is different than my uncertainty of the instrument. Okay. That's the whole idea of doing this calculation. Sure, to manipulate any number of decimal places, you click on the cell where you want to do, you see the cell is highlighted, right click, format cells, click on that, then new window will appear. In that window, you can see number in the first category and then category inside there, select the number. And then go to decimal places, put number 2. If anything they are deleted, put number 2. Or you can use these arrows, okay? Either way is fine. And click OK. Then I can cut down rest of the other decimal places. Make sense? Follow me? Okay.
Professor,
Yeah, what's up?
can you show us one more time how do you get all the values of the column at one time?
All the values means this average values, so average mean deviation.
No, I mean all the values you see at the absolute value, for example, L minus L.
Oh, you want to see what function which I use?
Yeah, yeah.
Okay, yeah, right here. You see that?
Okay.
So if you want to go get L bar minus L, what you have to do equal sign ABS open brackets L bar is this number, right? 182.61 minus highlight the cell,
Yes.
close brackets, enter button. And then you go back to the same cell, go back to the same cell, click on the right hand side very below, click and drag. Only this data set we need, okay? Don't do that for this part.
Okay, thank you.
Yep. Good, any questions so far? Everyone okay? And then please ask any question. This first few lab, I would like you to really gain these skills instead of, try to just sometime you watch and then later you think that I gonna rewatch and then do this. Instead, I would suggest you to try to do during the class. And then I would like you to gain this skill, okay, within first few labs. That's very critical to save time as we go into the next few labs, okay? All right, so next we take a look. Now you know how to do this in detail. This is in detail. But in the Excel, there's an inbuilt function for many of these things, like the average function. I can do average mean deviation very easily than this detail. How you do that? How you do that? You go into this cell, average mean deviation. You can see another cell here. You can go there, equal sign, type AV. Then the first function right here, it says returns the average of the absolute deviation of the data points. So that's the one exactly we need, which means instead of doing this detailed way, I can actually use this function directly. That's the idea of computational thinking, computational data analysis, right? So that's why people going behind this, right? So that's the idea of when you go into the very high end of this data analysis, the big data and then big data manipulation. So that's the term you hear always these days, right? Doesn't matter what field you are, medical, journalism, whatever it is, big data is the future anyway, some way. So your job gonna be some way connected to the big data. Doesn't matter whether you like it or not. So you have to know some information how to really go into that field. That will be useful, right? So the why computational is so important. You can write a function to actually minimize the amount of work you do. This is one good example. Instead of doing that detail, I can use this function. It's inbuilt. All you have to do, highlight the data set, close brackets, hit enter. Now you can see in terms of many significant figures, it's slightly different, right? Let's cut down this into two. Format cell, number, 2 decimal places. See that? Exactly same number. So that's the idea of computational data analysis, right? So you do this because you can save a lot of time. Not only that, you can get the exact accuracy and even more accuracy than you do manually. So that's the idea into the future. So you have to really get into thinking in this approach. Now let's do the same thing for the width, equal sign AV, average deviation, highlight the data set only, okay? Don't highlight this part, okay? Average this column, this cell, don't highlight that, only the data set, hit enter button, then reformat, number, only 2 decimal places. I'm gonna highlight that in a different color and see that separately. Then let's do this one. Equal sign AV, average deviation, only data set, close bracket, hit enter. Let's cut down this into 2 decimal places, format cell number, 2 decimal places. Let's highlight that in a different color. And then you can see what's the connection, okay? Let's highlight that in visible different color. Okay, that's good. And these are foremen, right? You can see now this number is slightly below, close to this lower line, which means I can go in the top here. I can make it center, right? So if I go into those, I think you know those simple formatting. If not, try to learn them. It's not difficult, okay? You don't need to take a class to learn Excel at all. It's very simple. You just play around, you can learn. Okay, question. Anybody have any question?
The only thing, Professor, is that you can also shift it to the center formatting,
You-
and then the
you
font
can.
is a little bit different as well from the rest of the table for formatting.
You can format the whole table if you want to, like highlight everything, make it like center everything, right? You just need to click here and then type of whatever the font you like. I usually use Cambria or Times New Roman, but that's up to you. I don't mind those things. But in terms of lab report, all the words you write, I think I set it into Times New Roman, font number 12, single column, and then no spacing, okay? No double spacing or anything. So that's important. But for this, you can format any way you like. Times New Roman is good, but you can use Cambria or maybe Calibri, whatever, doesn't matter much. Good. Any other question? And one other thing you can see now, these are function, right? For example, if you want to do this L minus L bar minus L, the absolute value, you can't really type that directly. You have to use the equation. Okay, let me show you that very quickly. Insert on the top menu, symbols, equation. Then it randomly go into anywhere, doesn't matter. You just click on there. You can see a lot of different formatting. And then you type the equation what you like. Then you click and drag, okay, wherever you want that. So that's what exactly I done when I writing this, okay. So those things I will let you to practice. The first few lab I will provide you that. But as the semester progresses, actually this lab's gonna getting more and more easier than the first few labs, and then I will let you to do on your own all the tables and everything. Okay, but first few lab I want you to follow exactly what you get. Okay, any questions so far? Everyone okay with that part? Okay, so let's continue now. Let's take a look now. In most of the experiment, we do what we call the percent error calculation. Okay, this error analysis and what we call the propagation analysis right here. This part we call the uncertainty propagation error analysis. Those error analysis not big part of the experiment later in the semester. But every single experiment in physics, physics 1, physics 2, and even physics 3, percentage error is one of the main part. Because why it is important, what you do in the percentage error analysis, you comparing two different things, right? That's all. Very simple concept. When you're comparing those two different things, you can do two different type of percentage error, right? One we call percentage error directly, which means you compare calculated value, for example, average calculated value, with the standard value I am expecting it to be. That's called percentage error. Percentage error only if you have a standard value. But if you don't have a standard value, later in the semester, you will see we do certain experiment, calculate the same physical parameter twice in the experiment. If I do that, then we're going to calculate what we call the percentage difference. Okay, that's similar, but very slight different. You can see the equation on your formula sheet, lab manual equation number 7. But when it come to later in the experiment, how to do that, I will explain very in detail that one, okay? But at this point, let's focus on percentage error because we have a standard value now, right? So how to do that? You see the equation here, right? I need to build that equation. Percentage error, equal sign. I need absolute values, parentheses, standard value 182.50 minus average value which I calculated, average length, close bracket, divide by standard value 182.50 multiply by 100. That's my percentage error between average calculated and the standard what I expecting to be this number. Now again, you can see,
Professor, can you show that one more time, please?
yeah. So let me copy that function maybe just below that. That might help. Okay, let us do that. Add another line here. Let me copy that function, then you can read that directly instead of rewriting. All right, that's the percentage error. Okay, PE is equal that function directly. Good. You see that function?
Professor,
Yeah.
you have J7 minus B17 over J7.
Mhm.
The equation in the experiment says E minus A over A. Wouldn't it be over B17?
No, but what it's telling you is that if you have a standard value, always it's gonna be relative to standard value. That should go to new denominator. Numerator doesn't matter, right? Because numerator is absolute value and the difference, right? That doesn't matter, but the denominator matters, okay?
Okay, thank you.
Yeah, because that it tells you to which one you comparing. Usually if there's a standard, usually always we're gonna compare to standard. That called the accepted value actually on your lab manual. A represent accepted value. Okay, that's the standard value. All right, now you see there's many decimal places. You can round it that to about like 2 decimal places. Technically now, when you're rounding the percentage error, so that percentage error not like the average mean deviation, right? Average mean deviation, I rounded that exactly to number of the accuracy which I can read. So that's important. But when you're rounding to the percentage error, that's no need to round it specifically to 2 decimal places, because that's not going to tell you anything about accuracy or anything, right? That tells you how much difference these two values, right? Then when you do that, then you can compare how many number of significant figures I should have. Like number 1, 5 sig figs, number 2, 5 sig figs, divide by 5 sig figs, which mean I can represent this one, right click, format cells. I can represent that one if I want to 5 sig fig easily by using scientific, right? Scientific notation, usually one number plus maybe 4 decimal places, 5 sig fig easily. So those are the places which I mentioned earlier in when you do the experiment report, you can't really do single, formatting for everything. I can't really highlight this whole table, do one single formatting everywhere, which is not much meaningful. Because sometimes we have to show accuracy in terms of decimal places very carefully. Sometimes we don't need to show the decimal places at all. We're not interested in that at all. Instead, what we're really interested is how many number of significant figures which had on that calculation, right? Percentage error is just an equation, so we don't care number of decimal places in that. Okay, question. Okay, so let's do this calculation for rest of the things. Now, percentage error happening only for these three. Okay, these cells should be empty. There's nothing to calculate on this. Okay, if you want, you can actually color that cell. Those are formatting. I'm not going to spend time. I'm going to show you only one of them. Right click, you can go format cells. Then you can go fill, and then you can put a color to that, right? So I need to fill that only cell. Automatic fill color, something you can fill a different color and then click OK. Let's see why it is not doing that. You can practice those things later. Okay, format cells, different color, that's a sample, and then I don't need any formatting. Okay, right there. So it's very simple thing. Okay, you can do that later as it is needed. Format cell, put a different color, and then click OK. That's it. it will color that cell differently, okay, because this should be empty. And don't worry about those coloring things like that. I don't care. Leave it everything white color, but fill what is needed. That's good enough. Let's do percentage error for the next one. Let me copy paste this equation, this function too. This function you can copy paste if you want to here and then retype, or you can retype from the beginning. Okay, let's retype to get factors. Equal sign ABS, parentheses open, absolute value or the standard value of width minus calculated value of width, divide by standard value of width, multiply by 100. And then I can reformat, right click, format cell. Let's do 5 sig figs. Just follow just the significant figure rule there. And you can see it's a very small number, okay, 10 to the negative 2. And let's do the same calculation for thickness equals sin ABS, open bracket, standard value for thickness minus average value for thickness, close brackets, divide by standard value for thickness multiplied by 100. And then that is sub to 3 sig fig. That's good. Okay, question. All right, so we can take a quick break here. Let's take a look. Let's take about like 10 minutes break and then we'll start moving into a next section. We have enough time, definitely. I would think we can complete all of these. We might not get enough time to do the sheet number 2. If that happens, we're gonna skip that. Okay, let's wait and see. I think we have about a little more than 1 hour. Maybe we have enough time. Let's see. Let's take a quick break and then start in 10 minutes, okay? Question so far.
So far, so good.
Okay, so let's continue then. Let's go into table number 2. So let's take a look now. The table number 2, there's no any calculation necessary. So what it's asking is that if you do any measurement in physics, we would like to write it down in standard format. Standard format means usually if you want to report the length, now you know this is the length average. This is the mean average deviation for that average length, right? So this is the measured value. This is the uncertainty of that value, right? So technically, what it asks you to write it down in standard format. Standard format is, now I can't write it down in generally. I'm gonna use equation. Okay, insert symbols, very end your right hand side, then click on the equation. Then I'm gonna write the average length which I calculated 182.61. Then you have to put the error. Now error is plus or minus sign. So you can take this sign plus or minus. Now in this case, error is not the error of the single measurement. Error is average mean deviation. That is 0.12. And the units, format in the given units, which is centimeter, right? So that's the standard way if you want to report any measured value in physics. So that's how you have to report that at the end, right? Make sense, Halovi?
Yes.
Okay, so you have to do now, for example, let's do this first one only. These two you can do easily. So now the next it asking, write it down in SI units. All I have to do, I can just copy paste this one and then bring it to here. Then all I have to do to convert into SI units, I can do this easily. I can put a brackets here. And then you know to convert into SI units, all you have to do multiply this by 10 to the negative 2, right? Centimeter into meters. So you can do that easily. Let's do that easily by converting that, by multiplying 10 to the negative 2. So let's see why my formatting is not appear. It's given as a shape. That's why. Let me rewrite that. Insert equation parentheses 182.61 plus or minus 0.12, close brackets. Now I need to multiply this whole thing. Multiplication sign 10 to the power negative 2. You can do that easily and nicely with this formatting. E to the power x. If you go in, you will see this formatting, right? So if you click that, you can do that nice formatting 10 to the power minus 2 and then unit meters. So then you click and drag wherever you want that. Okay. So the same way you have to do width and thickness. So you can copy paste those into here and then just rearrange the numbers, right? Just only the numbers are changing. The formatting and the units going to be remaining same. So I will let you to try that, okay, later. Good, any question? Okay, so then let's continue. This you have to try later, okay? I will let you to try that. But later. It's the same thing, only the numbers are different. Now let's take a look instead of that, a little bit more important thing. Now what we're going to do, we're going to calculate average perimeter, area, and the volume. Now what we're doing is actually, this is a rectangular three-dimensional object, right? Because of that, I can calculate area. So that is the top surface area, and then I can calculate the average perimeter. That means around the surface, how long around, and then the volume, right? Let's do that calculation first. If I do average perimeter, so what I do, this is a rectangular shape object. I adding all the length and width together. So the two similar length, two similar width. That's why you took this two out. You adding average length and width multiplied by together, right? Multiply by 2 equal sign 2 times parentheses average length value, you have it here, plus sign average width value, close bracket, equal sign, hit enter. So you will get the answer for the average perimeter. Okay, following? Now,
Can you redo that again, please, Professor?
2 times equal sign, the same equation right here. You just need to type that in Excel formatting, right? 2 multiplication is star button. Okay, star button is shift and number 8. That's the multiplication in Excel. Open brackets. Average length, cell number B17, plus sign, average width, cell number D17. Close bracket, hit enter button. Then you will get the answer. And then let's take a look at the unit first. Now, in terms of unit, you adding 2 centimeters together, so your unit gonna be centimeters. Okay, all of these this is square brackets you can see for every column. So those actually represent unit. I forgot to mention earlier that now unit for this part, this column should be same centimeter, right? You need to add that unit actually before we move to the next. So every column must have to have a unit. And then if there's a variable, that should be properly given. If there's a term we use, that should be properly given. You see that? Then only your table is completing. Okay, unit is actually so important. Without any unit, that whole column is actually has no meaning. So make sure you add the centimeter unit here. Now let's take a look. Now I have this calculated, right? What you're doing is adding two numbers together. So which mean if I follow the significant figure rule, you remember you go and take a look what's the least accurate number, right? In this case, both numbers are same, which mean in terms of accuracy, I can have 2 decimal places in this number. So you have to represent that accuracy. If you do this kind of analysis, you have to do that, right? So to represent right decimal places in terms of right sig fix, right click, format cell, number, and then 2 decimal places. Then you have right significant figure according to your calculation. Okay, question? Good, no problems. Okay, now let's take a look. Now you can see what's really happening here, right? I had a data set. So before I had a data set, I had a single number, right? Single measurement, error is the uncertainty of the instrument. Very simple, very easy. You look at the instrument, you look at the uncertainty, that's the error of this measurement. But if you had a data set instead of that repetitive measurement for one single physical quantity, then you have to do the average and the average mean deviation. Little bit more work than the direct error from the instrument, right? For one single measurement. And then we discuss about the percentage error too. Now you can see now what we're doing in the average perimeter, I actually manipulating two physical parameters together to get a different physical parameter. Now the perimeter is not directly measurable parameter. It is a result of two measurable parameters, right? If you do that, then your error calculation is completely different than any of the error calculation you done earlier. So now this is called the propagation of error analysis, because error is propagate with how many number of physical parameters you have inside the formula, and it propagate with what is the arithmetic you actually do inside that formula. So which means this equation is actually result of partial derivative of this equation. Now all we need from there, if you take in the Calc 3 class, then you can actually take the partial derivative of that, write it down the equation P is equal to times L plus W, and then take the partial derivative of both sides, delta P, which is equal other side. When you do the partial derivative other side, you have to go addition rule, and then you can get the answer very easily. So I'm not interested in proof of that, right? So you can take a look at that later, and we can talk about that later if you're interested much. Let's take a look how we do this calculation and then what are the differences compared to the previous. Now, previously, you have to identify that is very important, okay? I had one single measurement, many numbers for that single measurement, you do average. If you do that, you do average mean deviation. One single function, job done. But if you calculate something which is a function of many physical parameters, you have to take a look how many physical parameters involved, what's the arithmetic inside that function. Then you will get a new error calculation. Now let me show you how to figure out these accordingly, any of the new parameters you're going to do later in the semester. All you have to do this. There's two rules, okay? One rule, addition subtraction rule. Other one is multiplication division rule. There's actually three rules. The last rule is the power rule, like similar to your the math classes, okay, calculus classes. There's three different rules to pay attention. Addition subtraction rule, multiplication division rule, same here. There's no difference at all. And the power rule, which means, let's say you have some physical quantity which is actually look like this function right here. You add a b and then subtract d to get a quantity c. Now if you want to calculate a error of that c, now that is depending on error of each of this quantity itself. This delta represent, let me show you that also. Now there's two different delta you will see in this class, okay? All of these are Greek letters, right? Let me show you here. So delta. So there are two different delta you will see, okay? One is uppercase, one is smaller case. Insert symbols, go into symbols, then you will see this delta, this one. That is uppercase delta, right? And then you will see a small delta, lowercase delta, this one right here. You see that there's two different delta. This is also delta, this is also delta, okay? The smaller letter delta, uppercase letter delta in Greek letters. This uppercase letter delta usually in uncertainty represent measurement error directly. For example, now this one right here is actually, you can say uppercase delta L. If you want to represent that, insert symbols, If you do uppercase delta here, uppercase delta L is actually this number. So that is the direct measurement error for the length value. But if you calculate any measurement error, for example, now this one, average mean deviation, is actually calculated error by using this data set. If you do any error calculation, usually we're not going to use this uppercase delta. We usually write it down lowercase delta. So that's why it's written this way, okay? You get that idea? When you read the textbook and then if you compare these symbols, you have to really identify what it means, why it is sometime lowercase delta, why it is sometime uppercase delta, what this equation trying to tell me, okay? If you really distinguish those things, then it's really easy to follow through these things. Any question so far? Good? All right, so which means what I was telling earlier, if you have addition subtraction only in your equation, all you need to do, figure out the delta for the each variable, error for the each variable. You can see here, this is error for the each variable, and then square it, add all of them, take the square root totally. That is the error of this function z right here. So this is going to be same for addition and subtraction. You can see even you have a subtraction here, there's no any effect at all. Rule is same, okay? So that this equation number 17 you can use as a general rule for the propagation of error analysis for addition and subtraction. Okay, good. Any question? And next rule is the power rule, right? If you have the power rule, let's take a look at the multiplication and division rule first. Let's calculate this one first. Let's discuss the multiplication division rule in next, okay? Let me come back there. So let's do this calculation first. Now, I have length and width. I calculate the mean deviation for length and width. That is my delta L and delta W values. So I have all those numbers here. So I just need to do that calculation, right? So which means equal sign. Now you need this outer square root, which means everything should be inside the square root that you can do easily in your Excel by typing sqrt. So that tells the square root, open brackets, open another brackets, 2 times delta L, which is actually this number. Mean deviation you calculated for the length. Close bracket, power sign. Power sign is the small hat. That is, you can do shift and number 6, then number 2. Okay, then plus open brackets 2 times delta W, that is cell number D18, average mean deviation for the width, close brackets, power sign, that is a small hat, shift and number 6 and 2. Then close brackets again, because you have to close the bracket you open here. You can see each bracket has a different color now, right? So you can follow through easily. And also if there's an error, the Excel will tell you there's an error in the formula, go and take a look. Nothing much to worry, but you have to take a look carefully as you write it down, detailed functions, okay? Then hit enter. That's all. Then it will calculate the error for you. Okay, that is the total error. Now you can see these error values are very different, right? So earlier, this number is very different from the uncertainty of each measurement because I have the average now. Now you can see this number is further different, right? That is further different from the mean deviation reason. Now you have a mathematical arithmetic to get this function for the perimeter. So that is why you can see your error analysis also should be very different as the functions progress into a different level. Now again, this is the error. I'm not interested really significant figure here, but really interested to show how much the error relative to my given number, right? You remember that earlier when you write it down in standard format, this is the way you write, right? Your number plus or minus, what is the error? That's the standard way you represent your any given physical parameter. In that format, when you're telling your error, we are not interested in significant figures there. What we really interested is actually that accuracy, right? Because that is the error we're telling. We can't really represent 5 sig figure in the error. Instead, I should represent only the accuracy, right? Similarly, here, what we really interested the accuracy, which means I can go only down to two decimal places. Let's format this one, right click, format cells, number, and 2 decimal places. So now that is my error of my calculated perimeter. And the unit of the calculated perimeter, you see everything is squared and square root, which means unit should be same as centimeter. Okay, following question? Okay, now you can see this lab is very simple, right? Because what we're doing is, you can say this measurement can be done by anybody, right? Even 5th grader, if you ask you to give a meter ruler, ask him to measure this length, width, and thickness, he will do that, right? It's not big deal. Anybody can do that. That is not our interest at all. So our interest is actually in somewhere else. How to get the errors, how to write it down in real scientific format, and then how to calculate more errors as the equation is formulated by using different arithmetic. So that's our main focus, okay? All right, any question so far? Everybody got this function? Good? This function, right? Let me copy paste that function into a different cell. Those are the function you can actually use when you do the discussion. You can collect these function, maybe all the functions somewhere here. For example, different column. You can collect all the function. Let's see, this is delta p, right? So the delta p function is that one, and then as you progress in the Excel sheet, collect all those functions and then use those functions to discuss. When you do the discussion, I calculated the perimeter. Usually a discussion should be write in passive form, right? We don't write like I calculated. Instead, we write perimeter was calculated by using this way, and then error for the perimeter was calculated by using this equation, and then so on, okay? So don't write it down in physics in active form. In physics, usually we write everything in passive form. We usually don't write, I did this, I did that. We don't write it that. If very needed, we write usually we did, if it is like project report, otherwise usually in passive form. This was done this way. Okay, question. Let's do the area then. Area gonna be centimeters squared, right? You can use the equation to format that, or you can use this way, hat tan 2. And area, you know, average length time average width, average length, multiply, shift and number 8 is star button, and the average width. Hit enter button. You can see now many numbers there. And that many numbers really not much meaningful, right? So what we've done is the average area in terms of number of significant figures. We've done multiplication, so which means technically I can go 5 significant figures max. I cannot go anything more than that, right? If I keep the same units, I should go here only 5 significant figures. Format cells, number, 5 significant figure means 1. In this case, if you're going in this way, I have to go 0 decimal places because that will represent actually 5 sig figs. I can't have any decimal places in that way. Or if it is very large number, you know, we don't like to write, you know, these numbers when it go into like thousands of numbers. We don't usually keep that number as a thousands of numbers, right? So usually what we like to do is that format cells scientific. That's where the scientific notation is very important, because scientific notation comes when you have large numbers or really small numbers. To about like couple of hundreds, this number, not big deal, you can leave it like that. But 19,000, it's not really much meaningful, leave it like that. So let's write it down in scientific notation. Format cells, scientific. I need 5 sig fig in totally, which mean one number and then the 4 decimal places. So that will give you right scientific notation. Okay, good. That calculation is this, right? Simple. So B17 multiply D17, average length multiply average width. Okay, so let's do this calculation. Now you can see if I have a multiplication or division, I mentioned earlier there's 3 rules in terms of error calculation, propagation of error analysis. Addition subtraction rule earlier, which I mentioned, equation number 17, you can refer as needed later in the semester. And for multiplication and division, you can refer this equation as needed, actually this one. So number 27, that is more general one. You can see what that equation tells you. If you have a quantity Z, which is multiplication of X, Y, Q, and then divide by P, fractional uncertainty of that quantity, which is the fractional uncertainty of each of these quantity itself. You can see delta X over X, that called the fractional uncertainty, and square of that. Then you add all of them together. It doesn't matter whether it's division or multiplication, all the quantities must add together. If you don't have a P, this part will no longer be there. If you don't have a Q, this part will no longer be there. That's the idea, okay? I have actually typo here. You can see this should be delta P. I will correct that after the class. Okay, you can see that typo. If you see any typo on this lab manual, please let me know. Shoot me an email. That actually very useful because I'm writing all of these lab manual, spending a lot of time, but there's no any help in terms of college point of view. So technically nobody doing this because usually what we done until I started that Bergen, everybody asked you to buy $150 lab manual. Okay, so now actually I wrote this and then I gave to all the adjunct faculty too, and then most of them now they have their own, they manipulated, and then I think except probably one faculty member, everyone else now not asking you to buy a lab manual. That's a very big saving in terms of a student point of view. If you have anything, just see any typos, let me know, okay? Because I don't have anybody to take a look, any mistakes or anything. All right, so let's continue. So you get the basic idea, right? So the multiplication and division, same rule. Now, since this one, you can see I have 2 variables, L and W. Because of that, I have only 2 variables inside the square root. And then this division part right here, you can see I have to multiply because I'm interested only delta A. Let's do that calculation. Equal sign. A is actually this part you just calculated. Star SQRT, that is square root, parenthesis open, another parenthesis open, delta L over L. Now delta L is average mean deviation. Divide by L is average length, just above that, okay? Close brackets, hat sign, power 2, plus, open new brackets. You can follow this equation right here on the top, okay? Open new brackets, delta W, average mean deviation for the width, divide by width, close brackets, power sign, number 6, shift and number 6, hat sign, number 2, close bracket for the outer brackets, that is for square root. And then hit enter. Then you see I already formatted this one into scientific notation and the 5 significant figures because I can go exactly same number of sig figs I have here. Makes sense, but if you see a different number here than the scientific notation, you know how to format, right? Right click, format cell, scientific, one number and 4 decimal places. and then hit enter. Now you can see the difference, right? These are big numbers. This is in 10 to the 4, and then this is in 10 to the 1. Okay, pay that. Be mindful with that, because it looked like a big number here, like 20.1 error. Yeah, that is correct, but it is actually relative to 19,000 square centimeter. Okay, that's our unit here again, square centimeter. Centimeter power 2. Okay, question.
Professor, can you show me the formula that is in B38?
Yeah, so let me copy that to maybe somewhere here. If delta A. And as you continue with the calculation, collect this formula separately, because these are the ones you should include either in your discussion, or if you don't like to include that in the discussion, you have to collect a series of all these functions. Then you have to include all of those functions in your appendix C, okay, as a separate file. Because now we are not using the calculator to do any calculation. So because of that, you have to tell how you done this calculation. So we are using the Excel function. You need to show what function you use, okay? Okay, any question so far?
So when you're writing the report, you can just use your the grid from the Excel because it's going to be used in reference to the report?
Not in the reference. This should be going to appendix C. This is not a reference, really. You can't refer this one.
Oh no, I mean, so when you write it in the report and you still use like B18 over B17, is it generally understood that it's coming out of the Excel that is submitted with the report?
In the discussion, when you're explaining, like for example, you write it down how you did the mean average deviation, right? Then you can use that function. Yeah. Only in the discussion section, okay? And if you don't like to write the function there, or the other option is that you can actually add all of these, collect all the function like this one, like a series of function, then copy paste that into appendix C. That's the last appendix, right? Then you can refer that. Whenever you do the discussion, for example, you discuss about mean average deviation, then you can say the mean average deviation was calculated by using reference by using equation number 5 in appendix C. You can do that. That's fine, I think. Okay, there's two ways to do that. One is directly use that function to show how you did the calculation, or you can refer the appendix C. That's fine. Any other question?
Yeah, Professor. So I have the same formula and everything, but I'm getting 2.0190.
Then you are something wrong. Then probably right here, you need to take a look all these numbers, whether you have the same, and then take a look all the cell values, cell names, whether you have the same cell names here, something wrong in there. Otherwise, we're doing the same calculation. There's no reason to get the different numbers at this point. You need to take a look that function. Okay, I wrote it down here earlier. B18 over B17 is square of that plus D18 over D17 is square, then square root, and then outside you have to have A38 multiplied by everything. Okay, let me enlarge this one, then you can see the function. Okay, good. Let us do volume calculation then. How you do volume calculation? Length, width, and thickness equal sign average length multiply average width multiply average thickness. Enter button. There you go. Now volume is centimeter times centimeter times centimeter. You should get centimeter cube. Okay. Now, again, it's a large number, right? Now, these numbers, we don't like to leave it like that. It's really not much meaningful, right? So we have to change it to format cell, scientific, how many number of sig figs I can do. I did multiply 3, right? Then you have to go and take a look. How many number of sig figs I can have? What do you think? If I multiply these 3 numbers, how many sig figs I should have? My answer?
3.
3, right? Because you're going to go with the least number of sig fig, right? So let's format that one again then. Right click, format, scientific, only 3 sig fig, which means 1 number and then 2 decimal places. Okay, these are large numbers. Okay, all right, then let's calculate now the error for volume. Earlier I mentioned, remember that I mentioned you that it's the same rule for multiplication and division, right? General rule is equation number 27, which means if you have 3 parameters here, physical parameters inside the square root, you should get error, fractional error for all 3 multiplied by the calculated volume. Okay, let's do that function equal sign volume you calculated multiplied by sqrt, open brackets, open another brackets, delta L, mean deviation of length, divide by average length, close bracket, power sign, that is hat number 2, plus open brackets, mean deviation of width, divide by the average width, close brackets, power sign number 2, add open brackets, mean deviation of thickness, divide by the average thickness, close brackets, power sign number 2, close outer brackets, then hit enter. Let me copy that function also to here. That is the delta for volume equal, that's the function. Okay. So likewise, you can collect the function as you go. I forgot to mention that when we do this part, this table, I think you know those function, you can collect that as you go on. Add those function also here, right? What's the average function? One of them, you don't need to add same function for again and again. One calculate if it is similar calculation, at least one time that function. That will be the one you have to add either into discussion or the appendix C. Okay. All right, now this is already done in the scientific notation correctly up to 3 sig, right? This is good. Now you can see it's a large number. However, if you take a look, this is in 10 to the 4, this is in 10 to the 3. Really smaller error compared to this number, okay? Question. Let's put the units, centimeter cube. Okay, guys, any questions so far? Okay, seems to be no question. That's unusual. So usually this part has a lot of question depending on the group and the former previous experience with the Excel. I would suspect maybe you have a lot of experience with the Excel. Okay, it's actually good. Then we can proceed. Anybody have any difficulty? Okay, then let's continue. All right, so let's do this scientific writing here properly. Right now, it's asking you to write in standard format in given unit. And the given unit is, now we know perimeter, given unit gonna be centimeters, right? So the number you already calculated, right? I just need to copy paste that number here. Just copy paste that number. Now you can see if you copy paste the number, you have to be careful, right? You can't just copy paste. Instead, when you pasting, you have to go paste option. You can see there are several options. You have to do only numbers or the values, right? If you do that, you will get that number because you're copying a calculated value. If you're copying a calculated value, if you just do Control C and Control V, that might not gonna work, okay? So when you paste, but you go paste option, do values. That's in given units. Now this I have to write it down in correctly, right? Now this is not how we write it down correctly, right? You remember how we should write it down? That means the number plus or minus the error, right? So I have to do that correctly. Let's do that correctly, which means I have to use insert equation, because I have to get plus or minus. Insert symbols, very your right hand side top equation. Let's write it down 578.23 plus or minus, and what's the error for that? 0.29, and then given unit is centimeters, right? Okay, then you erase this part, I don't need that, and then I'm gonna bring that equation here and then leave it that equation here. Okay, if you want to merge cell, that would be better. All right, I can merge cell, highlight the cell, and then merge that too. Okay, equation. Everybody okay with that? That in the given unit, and then you know how to get the SI unit the same way. You just need to multiply by 10 to the negative 2. Insert symbols, equation, parentheses 578.23 plus or minus 0.29, close brackets, multiply 10 to the power value. It's better to use this formatting. You can see I can use the power here, 10 to the power minus 2, and then now I have a unit of meters. So that's the right formatting. You have to get practice when you do lab report too, because why I'm telling you this, you might think that it's going to take a lot of time, but this practice gonna makes your life easier when you grow into a next level, right? If you don't have this practice now, you might go through these classes very easily, but you will get difficulty at some point later. So you decide where you want to get the difficulty, right now or later. Okay, so that's something to keep in mind. Okay, so let's rewrite the area and the volume. Then I think we have enough time to quickly take a look at the other sheet. I think you can do area and volume, right? I don't need to do that too. So you can redo that easily, just rewriting. I will highlight that. Means you have to do this. Let me highlight exactly where I should do this one. And then you should do this, okay? Rest of the cells are empty. You don't need to write anything there. Can you manage that? Good.
Yeah.
Okay, so then we can take a look the other page too. If time remaining after we take a look at the other page, I will come back to here again to take a look briefly. All right, so what I skip is this two. Same way, you just need to look by looking at the first line for the length, and same thing you have to do here by looking at how you done the perimeter. You can write this, okay? Volume and the area. Okay, so let us go to the sheet number 2. I think we have enough time, about 20 minutes. That's good enough. Yeah. So let us go to table number 5 and then take a look how to do that table. Now, don't worry about too much on this table, and then this part what we're going to do briefly. We're going to discuss how to do the graphing, and then briefly we're going to take a look how to manipulate the graphical analysis, like putting the trend line, putting the parabolic line into the equation, and then extract the numbers from the fitting equation, things like that. But you will get more practice as the semester progress. From experiment number 4, every single lab has a graph and then has a data fitting, okay? So only up to lab number 3, you don't have the graphing, After that, every single lab during the semester, you have graph and data fitting. Now, what this table is telling you, this table is a data set for free fall object. Don't worry about that at this point. If you don't know free fall object, any of these parameters, don't worry about at all. We are not interested, knowing even that, right? So, right, for example, think about you are a computer scientist, somebody gave you a data set. Now, you're not gonna, study whatever he gave you. Like, for example, now there's a growing field called biostatistics, right? So there's a lot of data analysis going there. A lot of physicists working on this huge data analysis, right? But on those physicists, when they working on those huge projects, those field called the biophysics, they're not going to learn all the biology, all the cells manipulation, anything like that. They only look at the data set and they only look at how those data set connected each other, what that data set telling as a set when you look at it in certain way. Now this is question like that. Assume I don't know anything about the data set, okay? What I only know is that object is falling from some height to ground level. Only general things we know, right? So whenever object falling, gravitational constant plays a role, and then those things we know, right? And let's look at the data set then. What is given? Displacement of time of a free falling object. I forgot to mention a couple of things earlier. When you have a table, you can see there's a table name. Always you have to name the table. Table name usually should be on top of the table. Okay. Some classes, maybe they allow you to type the table name on the bottom, but I don't like that. I like to write it down the table name on the top in general. Okay. Pay attention to those things, how I formatted this. Those are I gonna check actually in your report. Okay. Now you can see I have a table number 5. Table telling you displacement of time of a free falling object. Now, this is a displacement, right? You can see many different data sets and the time. You let the object go, you find the displacement for after certain time. When the object is started, displacement is 0, time is 0. After 0.01 second, your displacement is 0.001. This is in meters. Okay, that's mean about like 1 centimeter, right? And what we done, we measure that repetitively. Now you can see repetitive data in here right on horizontal line, not the vertical line. See, those are the things you have to identify. You don't need to know whole thing, but as a computational scientist, as you analyzing the data, what you need to understand is those, how the data set is written, what I can understand by looking at data set. That's what your skill is. If you develop that, that will be useful to analyze the data set even without knowing that part of the science. Now let's go back to the table number 1. Look at it, how it written. Now length, you have repetitive data, but repetitive data written in downward direction. So I did all the analysis right in this column, right? Now, if you go into table number 5, you have a repetitive data, but repetition is written in horizontal line, which means if I do, now this bar represent average, right? If you do bar, you have to do the average of these 5 cells. So that's the idea. As the time progress, you can see I measure the displacement, but I repeat the experiment 5 times. That's the idea. I drop the object, measure the displacement after each 0.017 second, you can see, and then I measure that. Then I go back to the starting point, drop the object, measure again, go back to the starting point, drop the object, measure again, then I repeat that 5 times. Okay, now let's take a look what the question asking. Let's assume at this point, don't worry about any other thing related to this, formulas, anything. We don't know them, we don't care them at all. Okay, we just going to take a look how this data set can be understood in terms of graphing. Okay, that's all we're going to take a look. Now let's take a look what it asking next is the average, right? If you have the repetitive data, you have to do the average. You know how to do it now, equal sign, average. and then you highlight the data set, close brackets, hit enter button. Then if you do once, then to do all the other cells, you now click back on the cell, go back into that green color dot, right hand side lower bottom, and then click and drag. That will do the rest automatically for you. This column is automatically formatted into 3 decimal places. I think you should be able to see 3 decimal places. If not, that you have to reformat, because you see these are given, or the measured numbers have accuracy down to 3rd decimal place. Any calculated value directly should show that accuracy. Okay, good. And then right here you see delta y bar, that is the average mean deviation, or the mean deviation, right? So you know how to do that. Mean deviation equals sign AV, first function, average deviation, highlight the data set, only data set, close brackets, hit enter, and then go back to the cell, click on the bottom right side, a small green dot, downward direction. It will do calculation for you automatically. Now that calculation, you can see I have to give a little bit of more decimal places. Why? You see each number is actually beyond, accuracy of 3 decimal places, especially this area. You see that? So which means if I cut down to show the accuracy after 3 decimal places, technically it will be 0. So it's not much really meaningful. So sometime when you represent in the data, you can't really blindly follow this significant figure rule in the experiment. That really not help to anybody. Instead, you have to go and take a look what you're really representing. Whether your reader gonna read little bit of more information with fair enough accuracy or not. If not, then you have to modify your way of presenting the data, right? So that's why I leave it here like at least 5 decimal places instead of 3, because you can see these 4 numbers are extremely small, almost like look like no error at all. And then question asking you to do time to the power 2. You can see this is the time axis. To do the power 2 equal sign, click on the time cell. Power is, shift and number 6, number 2, hit enter button, go back to the cell, rightward, very bottom square sign, that dot, green dot, downward direction. That will calculate everything for you. That cell I'm going to keep maintain 3 decimal places. There's no meaning going more than that, but still you can see if I go into the second cell right here, I have 0.01. Now my calculated cell is actually look like 0. So those are the things you have to take a look, right? Now cutting down, what I really doing is actually I adding a lot of error here in this column, right? So I'm gonna go back, highlight the area, right click, format cells. I'm gonna increase 1 decimal place there because that cannot be 0. I have to have a number there because you have 0.017. If I do 0.00, then that's not meaningful at all, because the reason this data set, we're not really ending here our calculation. In between the calculation, you can have many data points and in many significant places, or the decimal places as you wish. What we really want to make sure at the very end, after you finish the calculation, you have to do the right significant figure. This is the middle of the calculation. So all the ending calculation on this part of the sheet is depending on these 2 graphs. Any question so far? Everybody got up to that? Okay, seems to be fine. Let's continue. Let's make these graphs. Okay, we're not going to do any calculation. I just gonna want to make sure whether you know or familiar how to graph in the Excel. Okay. First question: make a graph of average displacement versus time. Now, where's the average displacement? Column G. You calculated the average of these 5 trials. That's the average displacement, where the time column A. So I have to make a graph, right? There's a couple of different ways actually to make a graph, but the most useful way is actually make a graph sheet first and then add the data, okay? So first click elsewhere, anywhere on the sheet, and then go into insert. Then in the middle area, you will see charts. Then click on this scatter, click the scatter again. Then you will see a graph sheet without anything. The other normal regular way people do, they highlight the column where they want to graph and then do it. That also fine. But this is the most general way to make any sort of graph actually, okay? Now you have a graph sheet, right? Right here in the middle, empty area, that have a graph sheet. Then we'll add the data. You double click on the graph sheet. After you double click, you will immediately see this top menu icon changes, design chart. Towards your right hand side, third icon right here says the select data. Click on that. New window will appear. On your left hand side, you will see legend entries. Click on the add. Then you will see another small new window will appear. Click on series X values. That means I have to add my X values. Right now, your X value is going to be asking displacement versus time. If you write this way, time should be on X axis, right? You go into time, click and drag. That will highlight automatically the range of the data for the X axis. Delete everything on the Y values. Y values should be Y average. Go into here, click and drag. It will highlight the range you would like to see your Y values. Scatter plot. Then click OK button, click OK button again. Always in this class, everywhere you do is scatter plot only, okay? Do not do any sort of graph first. First is scatter plot, that should show only data points like this, okay? Should not show a line at all. If you do a line graph, that will be a reason for point reduction later in the semester, okay? But if you're not familiar a lot of about the graphing, nothing much to worry. We will discuss as the semester progresses, especially after experiment number 3 or 4, we will start graphing. Now don't worry about any calculation here. All I need to show you, if you have a graph sheet, everybody got this? Anybody have a difficulty getting that?
Can you show it one more time, Professor?
Sure. So all you have to do, click anywhere, not in the data table. Okay, don't leave the click on the data table. That will read automatically some data. Click elsewhere. Go insert chart in the middle right here on the top menu. Click on the chart. Just on top of that says scatter. Click on the scatter chart. And inside the scatter chart, first selection called the scatter. Click on that. Then you will get the empty space. That is actually our graph sheet. Double click that. Then you will see top menu icon changes, chart design, and your right hand side you will see select data. Click on the select data, new window will appear. Left to that window you will see button called add. Click on that. Then another small window will appear. Then inside that you will see series X values. Click the mouse button first inside the series X values. Now our X value should be time. Go and click on the first cell of the time column, 0, 0, 0, drag downward direction. It will highlight the area of dataset automatically. That will read automatically. You don't need to type anything. Okay? And then go to Y values, delete anything there. Then go into average Y column, click on the first cell, 0, 0. Drag downward direction till it reaches the end point of that cell. Then it will read that cell automatically, that column range of data. Hit enter, hit OK button once, then hit OK button again. Then you will see the graph.
Yeah, I got it this time. Thank you.
Yeah, and then if you make a graph, then you have to do a lot of things with the graph. Later, In the semester, we will talk about graph fitting, but at this point, don't worry about fitting. You will see graph look like parabolic, right? You see it increasing rapidly, right? So that look like half the parabola there. We can fit with the parabolic shape and then so on, but let's keep that for the later, right? Let's take a look what other things necessary. Now, if you have a graph, you have to have a name. Now, this graph name is displacement versus time. That's the graph name, right? And if you have an axis, you have to have axis name and axis unit. To add the axis name and units, there are different methods to do. You can use this plus sign here if you see that. If you don't see it, nothing to worry. Double click on the graph sheet. Go into your top menu bar. Left hand side, very top, you will see icon called chart elements. Click on that. Then you will see axis title. Click on the primary horizontal. Go back to the chart element again. Axis title, click on the primary vertical. Then you will see two new boxes appear here, right? There's a couple of different ways of doing this. I'm showing you one way, but if you experience enough with the Excel, you know another way to do this. Then you can follow that method. Nothing wrong. At any given method, if you're doing the same thing correctly, that's fine. Delete everything there. Just one click in the box. Delete anything there. Go back and add that. Primary horizontal, one click. Delete anything there inside and then type your axis name. Axis name is time. And then if you put the axis name, unit should be important. Unit second, usually go inside the square bracket. Go into vertical, delete everything there. Now type the name, that is displacement, right? Displacement, and then square brackets, unit meters. Now if you have all of these, then your graph is accurately represented, all the information. If anything missing, unit missing, axis name missing, and the graph is not in the whole graph sheet. For example, let's say your whole graph is in this area only. Those can be reason to reduce point, okay? You have to get practice how to represent graph very nicely with all the enough information. Don't worry about fitting any data at this point, just leave it like this, because we're going to do a lot of graph fitting later after experiment number 3. We almost out of time. Let us draw second graph and then stop there. Okay, it's not difficult. Now you know how to draw that. It says average displacement versus time square. Let's draw that too. Click elsewhere, insert, scatter. First icon is scatter, empty graph sheet. Then you double click, go into select data, then click add, go into x values. X values now should be t to the power 2, and then go to y values, delete anything there. Y values is still average displacement. Okay, not the time. T square versus average displacement. Let me delete this too. Okay, let me do that again. Select data, add x values t to the power 2, and then y values is average displacement is still, that is this. Can drag, click OK, click OK again. Now you can see what we done there. This is actually data manipulation. You can present data to the person who's going to read your report differently. Now this is same data, right? You can see this is one single experiment. It's the same data set. What we really doing, we manipulate the data to see how this object behave. Now you can see if you draw displacement versus time, you can see it actually square type increment, right? So it should be the power law equation. Now you can get the idea what's the physical law should be. It's a power law. But if you do the same by using y versus t to the power 2, that power is already included into x. Because of that, you can see linear increment. So that's just data manipulation. There's nothing new there. Okay, let's add the chart name. Give me 1 second, then we'll stop from there. Okay, 1 minute. This is displacement versus time square. And then you need to add, double click on the chart area, chart design, and chart element, axis title, horizontal, axis title, vertical, and then this one should be now time is square, right? And then square bracket is to the power 2, close bracket, and then this one is still displacement, and unit is meters. Now you can see that power right here, what is inside the graph, automatically goes into the axis. As a result, this becomes look like y equal mx graph. So those analyses very in detail we're going to do later in the semester after experiment number 3. Okay, any question? Anybody need any help or any part on this lab?
Question, Professor.
Yeah, what's up?
So to be clear, like how much of this is going to need to be submitted today for the?
You have to submit all of these. What I completed, that should be submitted by midnight, definitely. Okay, you can skip these places if you want to, because I did not complete, right?
How? So which table specifically should we skip
Everything,
then?
all of these, you can't skip any table. Only
Oh, we
this case,
can't. Okay.
you can't. Everything, all single calculation, whatever I done, you should be able to finish on your side with me. So you should be able to submit this by midnight, okay?
Okay.
But if you have any trouble like these places, you can skip. That's okay, I think. And yeah, go ahead.
Is this recording going to be available before midnight or no?
That I cannot guarantee because it's not me, it did WebEx, right? So
Okay, but it should automatically start uploading at least?
Yeah, it usually available like within,
like an hour and a half, 2 hours.
1 hour, yeah, usually 1 to 2 hours.
Okay.
By like definitely before 9 p.m.
Yeah.
But I can't really guarantee that. Really.
Yeah, no, of course, yeah. But
Okay.
yeah, just checking. Thank you.
Yeah, but for the let us stop here officially because we are out of time. Let us stop, and then if you have like individual question, you can wait in the call. And what I'm gonna say earlier is that if you have any difficulty,